All right, so today we're going to talk about the four kinematic equations, also known as the four motion equations. It's kind of a funny word. Have you ever heard of the word kinematic? It's almost like a made-up word, but it comes from, the word kinetic. What does kinetic refer to? Motion. Well, kinetic energy is a type of energy. Later on in the year, we'll talk about kinetic energy. And what do we mean by kinetic energy? The energy of motion. Or when you guys go to college, you'll hear about, or maybe you'll take this class, or you'll hear of other people taking a class called kinesiology. You heard of kinesiology? The study of body movements. Like if you're going to be a physical therapist, you take a lot of kinesiology. All right, so we call these the kinematic equations, also called the motion equations. And there's four of them. So it's kind of, it's like this is equation number 1, number 2, and I refer to them this way. Equation 1, equation 2, equation 3, equation 4. Now, let's define the terms. X is displacement. And what do we measure displacement in? Meters. A is acceleration. And what is acceleration measured in? Meter per second squared. V naught, that little zero there is naught. V naught is what? Initial velocity in meter per second. And then VF is final velocity of the object. And then lastly is T, which is time in seconds. Okay, the most common question that kids have when we're first learning the kinematic equations is, which equation do you use to solve the problem? And the answer to that is, it depends upon the data that's given. And sometimes there'll be 3 of the 4 that work. If you're solving for, let's say, displacement, and let's say you're solving for displacement and you have V final, you got V initial, you got time, and acceleration. If you know all those things and you're looking for displacement, then which equations would work? Could you use the first equation? Yeah, first equation would work. Could you use the second equation? Yeah. Could you use the third equation? No, it doesn't even have displacement in it. The fourth equation? Yeah. So sometimes 3 of the 4 equations could work, and then other times only 1 of the 4 will work. Okay, so it's trial and error. Okay. Now, what makes motion equations? What makes a problem involving the motion equations tricky? The thing that makes it tricky are problems that involve sign convention. Like to the right is plus, to the left is minus, up is plus, down is minus. So remember, what is plus and minus in physics? Direction. We talked about that, didn't we? Plus and minus in physics is direction. Okay, so we'll do an example of what I'm talking about. But just so you get the hang of this, let's look at this example that I have here. So can I revert this back to the original? Everybody got this? Okay, so what you want to do for these problems, we're going to look at this example here. What you want to do for these problems is always, always, always start with a diagram. Diagrams are the way to make a complex problem less complex. So here we have a car that has an initial velocity of 2 meters per second. So label this on your diagram. V initial is 2 meters per second. And if the car accelerates, so we're going to write down the acceleration, at 3 meters per second squared. Hey, and real quick, let's just review what that means. What is 3 meters per second squared? Well, yeah, that's the acceleration, but what does it mean? It means 3 meters per second every second. So every second that goes by, the car will be changing its velocity by 3 meters per second. So 3 meters per second, 6 meters per second, 9 meter per second. Okay. So what else do we have here? The time. The time is mentioned. Time, t equals 4 seconds. So what we're asked to solve for is the displacement from there to there. How far does the car go? And then the second thing is find the final velocity at the end of the 4 seconds. Okay, so this is a real straightforward, just so you understand, how these equations work. So take 2 minutes, that should be plenty of time. 2 minutes, solve this, and then we'll go over it. Okay, so the first question, find the displacement of the car. So which of the 4 equations can we use to find displacement? The first one. The only one that would allow, the only equation that's going to allow us to solve for x directly is the first one. Okay, so we go, oh, and you know what I forgot to mention? Hey, back when I taught you guys displacement, what did I teach you the symbol for displacement was? Delta x. From here on, I mean, technically, if we were going to be super meticulous about our symbols, technically we should be putting delta x in front, but pretty much every physics class I've ever heard of, x is understood to be displacement. I mean, what would you rather write, x or delta x? X. So x is understood to be displacement. So we go x equals 1/2 at squared plus v initial t, and then you plug in the numbers. 1/2, the acceleration is 3 meter per second squared for a time of 4 seconds. Make sure you square the time. And then v initial was 2 meter per second. The time is 4. Okay, so this comes out, when you punch this into your calculator, you get 32 meters. Now look, how do we get meters out of that? Like, how does the final answer come out as meters? Let's just check the units. Somebody asked that period 4. That was a really good question. So here's the equation. X equals 1/2 at squared plus v initial t. All right, so what should x come out in? Meters. Forget about the 1/2 because we're just checking the units. What is acceleration? Meter per second squared. Time is what? Seconds, but we're squaring it. That's second squared. Okay, v velocity is meter per second, and then time is second. Okay, so what happens over here to the second squared? They cancel, the seconds here cancel, and we end up with meter on the left and meter on the right. So it works. It comes out in meters. Okay, now, so we now know that the displacement is 32 meters. How do we find v final? Which equations could we use? Would the second equation work? Yes. Would the third equation work? Yes. Fourth equation? Yes. So to find the final velocity, we could use 3 of the 4. I think the third equation here is the easy one. So using that, you go v final equals v initial plus at. V initial is 2. The acceleration was 3. Time is 4. So this comes out as 14 meter per second. The final velocity over here is 14 meter per second. Okay. Now before you guys leave today, so I'm gonna kind of end this part of the lecture. Before you leave, we're going to look at a problem where you have to pay attention to sign conventions. So what do we mean by sign conventions? So sign conventions are to the right is plus, to the left is minus. So for example, like let's say that the initial velocity of the car, was 2 meter per second, but what if the acceleration were -1? So what's going on here?
Decelerating?
It's decelerating. So velocity being positive, that tells us the car is moving which way? The car is moving, look at the sign convention here. The car is moving to the right. The acceleration is negative, which means the car is accelerating which way? To the left. Is it possible to move to the right but accelerate to the left? Yeah. What are you doing? You're slowing down. Hey, one thing that I'll mention this later, but look, whenever your velocity and acceleration have opposite signs, so for example, velocity plus acceleration minus, or it could be velocity minus acceleration plus. Whenever you have this situation where velocity and acceleration are opposite each other, what's the object doing? Slowing down. Whenever velocity, and you might have to go home, you'll probably have to think about this, and we'll look at examples, but when velocity and acceleration have opposite signs, the object is slowing down. What if velocity and acceleration have the same sign? So either plus or minus and minus. What's happening if they have the same sign? The object's speeding up. It's going faster, faster, faster. Okay? All right.